There is a wide river. The water speed at the middle of the river it flows 8 kilometers per hour, and along the coast the water flows 6 kilometers per hour. The ship sailing down the river from the middle takes 13 hours to sail 520 kilometers. If it wants to go back to where it started, sailing along the coast of the river, how many hours will it take? Right now I am very confused. So there's two different water speeds, which I don't get because how can the water change? So which one should I use? Let's reread this problem. There is a wide river. Okay. The water speed at the middle of the river flows 8 kilometers per hour. At the coast of the river. Alright, so now I get it. The middle of the river and the coast of the river. The water flows at a different speed. So a ship sailing down the river from the middle takes 30 hours to sail 520 kilometers. If it wants to go back to where it started, which means going upstream, because first it was going downstream, then if you want to go back, it has to be upstream. Sailing along the coast of the river, how many hours will it take? Now that's more clear. So what are we trying to find? We are trying to find how many hours will it take, but right now there's many different values. There's like an equation to describe the middle of the river and another different one to describe the coast of the river. But in this whole thing, which element never changes? That's right, the velocity of the ship never changes. But the velocity of the ship is unknown. So what is the equation to find the velocity of the ship in still water? That's right, you got it. It is either the going downstream velocity subtract the water speed, or the water speed plus going upstream speed. But right now we only have going downstream. So I'm just going to use that. So first we need to find what is the velocity of the ship going downstream. And notice this downstream over here, I need to mark that it is from the middle, because that's where the problem gives us, from the middle of the river. So the downstream is 520 divided by 13. And if you're not getting why we're dividing right now, I suggest you go down to the description box down below and just quickly watch some of our other videos that will explain why. Anyways, 520 divided by 13 will give us 40. So our ship's velocity going downstream is 40 kilometers per hour. Now we have to subtract the water speed. What is the water speed? Well, right now we're talking about the middle of the river, so we have to look at the water speed at the middle of the river, which flows 8 kilometers per hour. So we have 40 minus 8, which equals 32. So our ship speed is equal to 32 kilometers per hour. So now we're trying to find, if first we are going along the coast of the river, how long will it take? So this isn't asking for the velocity of anything, it is just asking for the time. So we know that the total is 500 kilometers. And in order to find the time, we need to find the upstream speed along the coast of the river. So this is the water speed, right? That's the water speed. And at the coast of the river, it flows 6 kilometers per hour. So in order to find the upstream velocity at the coast, we do 32 minus 6. which equals 26. So it would mean that the speed of the ship going upstream at the coast of the river is 26 kilometers per hour. And now all we have to do is divide. So we would do 520 divided by 26. So what does that equal? It equals 20. So therefore the answer to this question is 20 what? 20 hours. That's our answer. Notice how the first step was just actually understanding the problem, because this actually added a whole other equation, because there was the middle river and the coast of the river. Then we thought, well, what doesn't change in here? The only thing that doesn't change is the ship. So we found the ship speed, and then just using the rest of our formulas, we calculated it to 20 hours. Again, if you did not understand why we were doing so much division here, I suggest you go down to the description and understand that in our videos on the distance, time, and rate formula. So thank you for watching, and problem 4 in the next video will be our last problem.